Alright, so this is going to be the last lesson on quadratics. If we have time, we'll go back and do some word problems that will revisit the quadratics, but this is kind of the main content behind it. I want to move on to the next chapters and get to the exponentials and logarithms. So here we go. So we have solving quadratic inequalities. So I want to know, given the quadratic of x squared plus 2x minus 8 is less than 0, where are all the values of x of that quadratic where the output is less than 0? So which x values will I plug in to get a y value that is less than 0? So the first step to do this algebraically would be to solve for the zeros. So you want to factor it if it's possible. If not, you now have completing the square and the quadratic formula. Completely your choice. In this case, I chose one that was factorable. So since I'm looking for the zeros, I want to know when the quadratic is equal to 0. And so I went ahead and factored, solved, and I knew that when x is negative 4 and when x is 2, those are my zeros. Now I also made those open circles because it is a less than symbol, not a less than or equal to symbol. Now I just sketched the graph. I knew it was a positive quadratic, so it's going to be going up. And I didn't really care where the vertex was because that's not what's important. Now what I'm trying to know is the shading going to be here or is the shading going to be on the outside? Now if the shading is on the inside, my solution set will be between negative 4 and 2. If the shading is on the outside, my solution set will be everything less than negative 4 or everything greater than 2. So we could solve this graphically by graphing the quadratic, shading appropriately, and then we'd see, but it might be a little bit quicker to do it algebraically. So that's what I chose to do. So I picked 3 distinct points that are definitely on the outside and on the inside of the parabola, and I'm going to test those points. So the first thing I did is I plugged in negative 5, and I found that it did not make a true statement, so then the shading won't be out here, which now you can probably jump to the conclusion that it has to be in here, but let's keep going. I plugged in 0, it made a true statement, so I know that this is a solution. And then last step, I plugged in 3, and I got that it wasn't a solution. So I can conclude that my shading would be found in here. So therefore, my solution to where this quadratic is less than 0 will be between negative 4 and 2. Now that's going to be my third step, is to write the answer. So since we have a range of values, it's a solution set. And we can either use our set builder notation or our interval notation. So the set builder notation would have that awesome bracket and all values of x such that, and then x would be between negative 4 and 2, again, less than, not less than or equal to, because of this symbol in the original problem. Or you can use your interval notation, and I chose parentheses because it is less than and not less than or equal to, and then negative 4, comma 2. Remember, if it was equal to, then you would use that lovely square bracket. But since it's not, we don't have to. And so that's how we solve quadratic inequalities. Now we're going to try these 2 problems. They're a little tricky, so be careful. Also be aware of your inequality symbols and try to factor it. And again, if it's not factorable, you might need to use the quadratic formula, or completing the square. I'll post pictures, and starting probably next week, we will move forward with something other than quadratics. Also want to let you know I'm having knee surgery, torn meniscus, it's awesome, on Monday. So I will not be posting Monday, maybe even Tuesday next week, depending on how I feel. But we'll see. Anyway, good luck.